Hello everyone, hope that you are all doing well. In the last few sessions, we have discussed that a force could be a push or a pull. A force arises due to the interaction between two objects. Force has both magnitude and direction. The change in speed or change in direction of motion or both implies change in state of motion of the object. A force can cause change in shape or change in size or change in state of motion. Keeping these things in mind, we are going to discuss some things. I am here today with my little friends Spurti, Neha and Gayatri. We are going to discuss some things which are very much interesting. We will start with an activity. I hope you are all ready.
Yes sir, we are ready.
Look at this. I have a wooden block in my hand. See, I am going to keep this block on this table. Okay? Can any one of you give a gentle push on this block? A gentle one. Okay?
Yes.
Did you apply force?
Yes sir, I applied force.
Did the object move?
No, it did not move.
We have already studied that a force can change the state of motion of objects. It can change the shape and size. Did you study?
Yes,
we studied it.
I am confused now. What happened to the force that I applied? How can there be a situation in which there is no effect of the applied force?
Okay, don't worry. We are going to discuss about it more. In the last few classes, when we discussed about the force and its effects, we have seen that a force can cause the change in state of motion of objects. But we have seen that application of a force doesn't guarantee the change in state of motion of an object. There was an activity. Do you remember?
Yes, sir.
Okay. So, Gayatri, can you push this block gently from this side? At the same time, Spurti should push this block from this side. We see that the block is not moving.
Yes, sir.
Yes sir.
So, when you are trying to move an object by pushing it, and if your friend is also pushing it from the other side with the same amount of force at the same time, then the object doesn't move. Okay. Spurti, from this situation, what can you tell about the earlier situation when you tried to move the block by pushing it, it did not move. So, what is your opinion in this?
Yes sir, now I understand. I think there is another force acting on the same body at the same time. When we are applying this force to slide it, and this force may be opposing the applied force.
Yes, that is correct. There is an invisible force. What does this force do?
I think it was opposing the motion of the object.
That is exactly what it does. So, this force opposes the motion of these objects. We call this force as friction. In all life situations that we generally come across, friction is present. Okay, let us do one more thing. Neha, can you push this block gently and see what happens? Okay, Neha, did you apply force?
Yes, sir. I did.
In which direction you apply the force?
Sir, in this direction.
Okay. So, in this case, what will be the direction of the friction?
Sir, in this direction, opposite to the applied force.
Okay. Now, Gayatri, you should give a gentle push on this block from this side. And when you are doing like this, you should explain what is happening.
Okay, sir. I gave a gentle push on this block in this direction.
The block doesn't move because the friction is acting in this direction opposite to the applied force.
Very good. So, when we apply force on objects, friction comes into play. So, whatever be the direction of the force, the friction always acts in the opposite direction. Look at this. I am applying force on this block in this direction, so the friction is acting in the opposite direction. So, the block remains at rest. Now, if I increase my force, the block doesn't move because friction is again acting. If I increase again, if I keep on increasing this force, at some point the block starts to move. Let us see what actually happens in this situation. When we apply a force, friction starts to act, and the friction is opposite to the applied force, and the total force is 0, and the object will be at rest. When I increase the force, friction also increases. This friction has a special property of self-adjusting and making the total force 0. So, whenever I applied the force, it did not move in the beginning because friction is also increased. But the friction has a limit. If I increase the force beyond this limit of friction, then the block starts to move. This friction, which is keeping objects at rest when an applied force is acting on it, is known as static friction. I hope these things are clear to you.
Yes, sir.
Let us do one more activity. Shall we do it?
Yes, sir.
See, I have kept one book on the top of a wooden plank. See, what I am going to do, I am going to tilt one end of this plank slowly. See, when I tilt, the book is at the same position. If I tilt more, the book is again at the same position. If I tilt more, slowly the book starts to slide down and it comes down. So, in the beginning, the book was not moving. Something was holding this book.
Yes, sir.
Yes, sir.
And when I tilted more, it started to move. What actually happens in this situation? Do you find any similarity between this case and the case of the block in which you applied force and then increased?
Yes, the book remains at the same position because of the static friction between the book and the plank. The plank is tilted, the gravitational force tried to move the book down, but the friction opposes it. As we tilt more, the gravitational force is more. The friction also becomes more and the book doesn't slide down. As you told, there is a limit for the frictional force. If we increase the gravitational force further by tilting the plank, the book starts to move and it slides down.
Very nice. So, if we consider these two situations, the situation of the block resting on the table and the situation of the book on the tilted plank, the action of the applied force and the friction happen in the same manner. Now, I have a question to you. When we apply the force and overcome the friction, when the objects start to move, then will there be further any friction acting on it? Let us see this. For this, we are going to do an activity. Are you ready?
Yes, sir.
Now, I have a ball in my hand. I am going to keep this ball on this table. Gayatri, can you push this ball gently? Observe the motion of the ball. Why does the ball move?
Sir, because I pushed it?
Correct. Did you notice the moving ball? What happened to it?
It stopped after moving a certain distance.
So the ball which I kept on this table changed its state of motion from state of rest to state of motion because Gayatri pushed it. After pushing, the ball started to move. But we have seen that the moving ball is stopped. After moving certain distance, it stops. I have a question. Who is applying a force to change the state of motion of this moving ball? What is the reason for the ball to be stopped after moving certain distance?
It looks like that there is friction acting on the moving ball also.
Very good. That is correct. So, in all life situations, friction is present. So, when two objects are sliding on each other, there is a friction acting in between these objects. So, the friction acting between two sliding objects opposing motion is known as sliding friction. Look at things. All moving things are stopped after some time. Can you give some examples?
When the fuel of a vehicle is burnt out, the engine stops and the vehicle is stopped after moving some more distance.
Yes, that is correct. When the fuel of a vehicle is burned out, the engine stops. It is the engine which gives force for the vehicle to move. So, when there is no force, still friction is acting between the tire of the vehicle and the ground. So, the friction opposes the motion of the vehicle. That is the reason after the fuel is burned out, the vehicle moves for some more distance and it is stopped. Can you give some other examples?
When we stop pedaling a bicycle, it moves for some distance and stops.
Yes, when we stop pedaling a bicycle, actually we stop the force acting on the bicycle to move it. Still, there is friction acting between the tire of the bicycle and the rod. This friction is opposing the motion of the bicycle. So, when we stop pedaling the bicycle moves for some more distance and then it stops. Is there any other example?
The blades of a moving fan stops after a while the fan is switched off.
That is also correct. When we switch off a fan, the force which is running the blades of the fan is no more. So, when there is no force, still friction in the fan will be there. This friction is opposing the motion of the blades of the fan. So, after switching off the fan, the blades will be moving for some more time. Finally, it will be stopped. I hope all these things, whatever we discussed till now, is clear to you. Let us do one more activity. Are you all ready?
Yes, sir. We are ready.
See, now I have a carom striker in my hand. Spurti, can you give a flick with your fingers to the carom striker? And you should explain what is happening. Okay?
Yes, sir. I flicked my fingers and hit the carom striker. It moves because of the force of hitting. After moving a certain distance, it stops. It is stopped because the friction is acting on the moving striker in the opposite direction.
Okay, that is correct. You explained it nicely. So now Gayatri, can you do the same activity from this side? You flick with your fingers to the carom striker and see what is happening, and you should explain to us what is happening. Okay?
I flicked my fingers and hit the carom striker from this side. It moves in this direction because of the force of hitting. After moving a certain distance, it again stops. It is stopped because of the friction it's acting on the moving striker in the opposite direction.
Yes, that is correct. So now we discussed many things. Can you tell me what are the things that you studied from this discussion?
Sir, today we discussed the force of the friction opposes motion of objects.
Friction acts in the opposite direction to the applied force.
Whichever be the direction of application of the force trying to move the objects, friction always acts opposite to the applied force.
You are all correct. I am very happy that all of you understood the things properly. Now, I suggest you to go and read your science textbook and understand the things. Try to observe around you and see the situations and try to identify the effect of the force in these situations. You should write your observations in your notebook and show it to your teachers. Okay? Let me ask you one thing. Why do we fall down when we step over a banana peel? Why is it difficult to walk on a wet, smooth floor? Why the jar of a mixer grinder is hot when we are working it for some time? You are all interested to know these things, right? Do you know that there is something related with friction in all these situations? So these things we are going to discuss in coming sessions. Okay? So now I stop our discussion here. Thank you all.
Thank you, sir.
Thank you.